Okay, so this is section 3.2, multiplication and division of decimal numbers. And so our objectives are multiply decimal numbers, divide decimal numbers, how to calculate an average, round decimal numbers, solve practical problems involving decimal numbers. So a decimal number is really a fraction with a power of 10 as a denominator. For example, 0.5 is really 5/10. And you can see it has one decimal place, and our 10 has 1 0. 0.85 is really 85 over 100. Got two decimal places, so 2 zeros. And 0.206, and we would read that, and that's why we would read it 206 thousandths when we talked about how to read the decimal number, because it has three decimal places and 3 zeros in our denominator. So multiplication of decimals is easy to understand if we think of it in this way. 0.5 times 0.3, or 5/10 times 3/10, is really 5 times 3 is 15 over 100, so it's 15 hundredths. So let's work some examples with this. If we take 3.2, and I'm just going to write the number like a normal number, and I'm going to add my decimal at the end. So here's what I know. This one has one decimal place. This one has two, the 4 and the 1. So we add those together. That means that my answer should have 3 decimal places. And we'll deal with that at the end. So I'm just going to treat these like we would if they were regular numbers without decimals. So I'm going to say 1 times 2 is 2. 1 times 3 is 3. And then we would move over to the 4 and multiply, but we know that that's not just a 4, it's a 4D. So we put a 0 down here. And then 4 times 2, 8. 4 times 3 is 12. And then we would want to add those together. So we're going to get 2. 8 and 3 is going to give us 11. Carry our 1. Okay, so we've got 1,312. But my answer is supposed to have 3 decimal places. And right now the decimal is here after the 2. So we would move it back. 1, 2, 3. So the decimal place should be right here for it to have 3 decimal places. Okay, so if we follow the same principle that we just got through following, we just write these down without the decimals. We would just do 3 times 2, which is 6. But we know that this has 1 decimal place, and this only has 1 decimal place. So when we add those together, we get a total of 2 decimal places. Well, right now, the decimal would be after the 6. So this would be 1, but we'd have to move it one more place to get 2 decimal places, so we would have to put a 0 in front of it to get our answer. 2.5 times 0.5, so we're going to say, we want to write that without the decimals. We're going to follow the same procedure, so we're going to say 5 times 5 is 25, so we would write the 5, carry our 2 up here. 5 times 2 is 10, plus 2, which is going to give us 12. Okay, and then we need to deal with the decimal. So we've got 1 decimal here and 1 decimal here. So our answer should have 2 decimals. So we would move it, we would start right here, 1, 2. So our final answer is going to be 1.25. Okay. So we've got we're going to write those down without the decimals. 5 times 2 is 10, carry our 1. 5 times 0 is 0, plus 1 is 1. 5 times 3, 15, carry our 1. 5 times 4 is 20, plus 1, it's going to give us 21. Now when we multiply by 0, we don't get anything, so we don't really even need to write that step down. But when we multiply by 2, we know this is not just 2, it's 200, So 2 times 2 is 4. 2 times 0 is 0. 2 times 3, 6. 2 times 4, 8. Then we're going to move to our 1. 1 times, so this is not really just a 1, right? It's a 1,000. So we've got to put 3 zeros. 1 times 2, 1 times 0, 1 times 3, 1 times 4. Okay, and then we're going to want to add those together. It's going to be 11, so we're going to have to carry our 1 there. So I am 5, 1. These are, I'm just jotting down the numbers that I got down there. Now, 3 decimal places, 2 decimal places. So my answer should have 5 decimal places in it. Right now it's here. So 1, 2, 3, 4, 5 decimals. So my final answer would be 51.8391. And remember that you don't have to put the 0 on the end, but you can if you want to. One nice thing about a calculator is that it counts decimal digits and automatically adjusts the answer in any calculation. But to get an estimate of the answer, you must still understand the process. So we've got a real-world problem that says an automotive tech earns a base pay of $21.46 per hour plus time and a half for overtime work exceeding 40 hours. If the tech worked 46.5 hours in 1 week, what would be their gross pay? Well, we know that they would earn $21.46 for the first 40 hours. And I'm going to go ahead and work this problem in the calculator. So I'm just going to take 21.46 times 40. So for the first 40 hours, they're going to get $858.40. Okay, now it looks like if you take 46.5 minus 40, that they have worked 6.5 hours of overtime. Okay, so we've got 6.5 hours. And if they were just working the normal, they would get $21.46, but the employer says that they're going to get time and a half, right? They're getting time and a half for the extra work. So we're going to multiply that by time, which would be 1. So they automatically get the $21.46, plus they get an extra half of that for the extra hours they worked. So 6.5 times 21.46 times 1.5, that's going to come up with 209, and it's 0.235. So we would, since it's 235, the 5 is going to make the 3 round up to a 4, because we're talking about money, so we have to stop at the second decimal place. Well, then last, we would want to add those two together to figure out what the total pay was going to be. Okay, so you could also do this part in your calculator. And so they would have a total gross pay of $1,067.64. Okay, let's talk about division. Division of decimal numbers is very similar to the division of whole numbers. So we can write 6.8 divided by 1.7 as 6.8 over 1.7. And so 6.8 times 10 and 1.7 times 10 would give us 68 over 17. Okay, so we've got an example of dividing, long division. So it says step 1. If we've got 6.8 divided by 1.7, you can tell that they put the number that's getting divided right underneath the rooftop, and they put the number it's being divided by on the outside. Then they said if it's 1.7, we're going to change these to whole numbers, so move your decimal one time, so it's 17. Well, if you move your decimal here one time, you also have to move it for the 1.8, or for the 6.8. And that's how they've got 68 divided by 17. Now they permanently move their decimal place to here. Okay. So they ask themselves, will 17 go into 68? Yes, it will, 4 times. 4 times 17 is 68, and then they got a remainder of 0, and their decimal was after this, so the answer is 4. So let's look at this. Let's work a few examples. So if we start out with this problem, we would say, how many times will 2.4 go into 1.38? Well, to make this, you want to make this just be a regular 24, so I would have to move my decimal once here. If I move it once there, I also have to move it once here. So we would have 24. How many times will 24 go into 13.8? And so we're going to permanently place our decimal there. 24 won't go into 1, it won't go into 13, but it will go into 138. So 24 is very close to 25. And I know if I have 5 quarters, that's 125 or $1.25. So I'm going to say that the best, and then because the next one would be $1.50. So I'm going to round to 5. 5 times 4 is 20. Carry our 2. 5 times 2 is 10 plus 2 is 12. Then we're going to subtract. So we're going to bring down our 8. We're going to bring down our 1. 24 won't go into 18, so I need to add a 0 here. Well, will 24 go into 180? Okay. Okay, and so we've got, how many times will 24 go into 120? And so we did 7 times 24 and got 168 and subtracted. And we brought down our 0 because we still didn't have a remainder of 0. So let's try 5. 5 times 4 is 20. Carry our 2. 5 times 2 is 10 plus 2 is 12. So we got a remainder of 0, which means we can stop. And our answer would be 0.575 or 575 thousandths. Okay, so on this one, we're going to say 2.6, which the 2.6 would go underneath. And then our 0.052 would be on the outside. And so we're going to have to move that 3 decimal places to get to this. So we would have to move this 3 decimal places, but there's only 1. So we would have to add 2 zeros to get to where that needs to be. So if we rewrote this, it would be 52, because we don't really need the 0 in the front if we move the decimal place. And then we've got 2,600 with our decimal here. So will 52 go into 2? It won't go into 26, but it will go into 260. Okay, so let's try, I know that if you do 50 times 5, you get 250. So let's try 5. 5 times 2, it's going to give me 10. Carry your 1. 5 times 5 is 25 plus 1 is 26. Remainder of 0. Now, you don't have to really keep going here, but what you need to realize is you can't just leave this blank. So you're going to need to put 0 there, and that's going to be your final answer, 50. Okay, here is a real world problem. It says, how many pieces of plywood that are this thick are in a stack 30 inches high? Well, we've got the same unit, so that's good. So what we're trying to do is do 0.375. How many times will it go into 30? We're going to have to move our decimal place 3 times, so I'm going to have to move my decimal place 3 times here too. So I would have, how many times will 375 go into 30,000? My decimal place would be right here. Well, 375 won't go into 3, it won't go into 30, it won't go into 300, but it will go into 3,000. Okay, so what should we try there? That might be a guess and check kind of thing, but I'm going to start off with 8. 8 times 5 is 40. Carry your 4. 8 times 7 is going to be 56 plus 4, 60. Carry your 6. 8 times 3 is 24 plus 6 is 30. So when we subtract, we're going to get 0, but we still need a 0 here. So the answer to this problem, 80. We can get 80 pieces of plywood. Okay? So let's talk about rounding decimal numbers. Calculations involving decimal numbers often result in answers having more decimal digits than are justified. When this occurs, we must round our answer. The process of rounding a decimal number is very similar to the procedure for rounding a whole number. The only difference is that after rounding to a decimal place, all digits to the right of that place are dropped. The following examples illustrate this difference. So, if we want to round 34,782 decimal, right, and 462 thousandths. If we want to round that to the nearest thousand, well, we would stop at the 35, and we would look next door, and that's a 7 or above, so it would become 36,000. And we wouldn't even need any decimal places. Okay, if we want to round it to the nearest 100, which is what they've done right here, if we want to round to the nearest 100th, we're talking about the hundredths place. So this is the tenths place, this is the hundredths place. So you would look next door, and if this number's 5 or bigger, you would round up, but it's not. So we could stop at the 0.46. You could put the 0 if you want to, but you could also just leave it like this. Okay. There are a few specialized situations where this rounding is not used. Some engineers use a more complex rule when rounding a number that ends in 5. In business, fractions of a cent are usually rounded up to determine the selling price. So 3 items for 25 cents or 8 1/3 cents is rounded to 9 cents. So I know that we did a problem a while ago where we rounded up with money. They're saying they always round up with money. So if it's 0.3, then it doesn't matter if it's 5 or bigger, they're going to go ahead and round that up when it's talking about money. So in a division problem, okay, so we have 4.7 divided by 1.8. So we've already taken care of moving the decimal, and they're down to 2.61. And we've got 20 minus 18. But the answer says that the problem says we just have to round to 1 decimal place. So we don't need to keep, even though this problem is not done, we don't need to keep going. But if we're rounding to 1 decimal place, we at least need to have 2 decimal places to make the determination if that 1 is going to stay a 6 or round up. And since it's a 1, which is smaller than 5, it's going to stay the same, and so it would round to 2.6. We would drop that 1 off. Okay. A homeowner in the Midwest recently spent $9,400 to convert his heating system from heating oil to natural gas. His heating costs fell from $2,570 last winter using oil to $1,120 this winter using gas. The homeowner wishes to know the payback time for his conversion costs. Round to the nearest tenth of a year. The first thing I would do is figure out, well, what is he actually saving per year? Okay, so it looks like he was paying $2,570, and now he's only paying $1,120. So he is saving $1,650 per year. He spent this much on the heating system. So how many years would it take for him to get his money back? So if we divide those, okay, so we're going to take 9,400 and divide it by 1,650. Pardon me. So you might have to guess and check a little bit on this, but I'm going to make an educated guess and say that it's 5 would be the first thing we would start with. 5 times 0 is 0. 5 times 5 is 25, carry your 2. 6 times 5 is 30, plus 2 is going to be 32. And then 5 times 1 is 5, plus 3 is 8. And if we went over, we would know we needed to go down here. So when we subtract, we're going to get 1,150. Okay, so that won't go. So we're going to try the next. We're going to have to add a 0. And keep in mind our decimal is right here. And this says that we can round to the nearest tenth of a year. So the tenth is the first decimal place. So we're going to need 2 decimal places. We do a 6 right here. 6 times, so I'm going to bring down the 0. 6 times 0 is 0. 6 times 5 is 30. Carry your 3 this time. 6 times 6 is 36, plus 3 is 39. And then 6 times 1 plus 3 is going to give us 9. So when we subtract, we're going to get 1,600. Okay, and that is 1 decimal place, but in order to tell if we're done, and we don't need to round that up to a 7, we're actually going to have to add 1 more 0 and try this again. So it looks like I could go up 1 number here. So 7 times 0 is 0. 7 times 5 is 35. Carry your 3. 7 times 6 is 42, plus 3 is 45. Carry your 4 this time. 7 times 1 is 1, plus 4 will be 11. So I'm going to make this a 10, so we know we've got to back up. So 4,450. So I still have a remainder, but I can stop this problem because I have this digit. And this digit tells me that the 6 needs to be rounded up to a 7. So my answer would be 5.7 years. It's going to take 5.7 years to start, how did they word it? That's going to be when I start getting payback after that. Anything after 5.7 years, I'm going to end up saving money after I've spent this initial 9,400. Okay. So remember that when you're doing order of operations, that still applies to decimals. So if my problem is 12.46 minus 2.5 times 1.7, I would need to multiply these two first, which is how they came up with this. Then I would need to subtract. To calculate 6.8 divided by 3.5 minus 2.7, parentheses comes first, so they calculated that first, and then they did the division. So remember, you've got to do parentheses, exponents, multiplication, division together, addition and subtraction together from left to right, even whenever you're doing decimals. So how do you work a problem with averages? So suppose you need to find the average of, to know the diameter of steel connecting pin. As a careful and conscientious worker, you would probably measure its diameter several times with a micrometer. And when you're measuring with a micrometer, you're getting something that is very, very small. So your eye may not be able to see correctly every single time. So they measured it several times and they came up with these numbers, and so they want to find the average of this. So they would take all of the numbers and add them together. Okay, I'm going to try to squeeze these in. I'm running out of room. And then they would divide it by however many there were. So there's 1, 2, 3, 4, 5, 6. So it's very important when you do order of operations that you add the top and find that answer and then divide by 6. So I'm going to add the top real quick. And so to be honest with you, I did that a couple of times in my calculator because it's easy to type one of those numbers in wrong. And so I do it at least twice until I can make sure that I get a number that's in agreement. So I added those up and then I'm going to divide by 6. And now did they tell us what they wanted us to round to? So if they did not tell you what the round to, you're going to use what these numbers are. And so I got 1.3736, and then the 3 keeps repeating. Okay, so this looks like it has 4 decimal places here, so I would want to stop, look next door, and since it's smaller than 5, the final answer would be 1.3736, and I would stop there. And this is micrometers. Okay. So when you calculate the average of a set of numbers, a usual rule is to round the answer to the same number of decimal places as the least precise number in their set, which our set all had the same amount of decimals. The one with the fewest decimal places is the one you want to round to. So the average of 4, 6, 4, and 5, they've taken those numbers, so they would do 4 plus 6 plus 4 plus 5. To get their 19, they divided by 4 because there were 4 numbers. And if you'll look at this, none of these had decimal places. That's why they chose to round to the ones place, because they considered their decimals. So if we do 2.41, okay, we've got 1, 2, 3, 4, 5, 6 numbers, getting 22.69 divided by 6. Okay, that's going to be 3.7816, and my 6 keeps going. Okay, but I'm going to consider the least amount of decimals. So this has 2, this has 2, this has 2, this one has 1, and this one has 2. So we're going to round to the one that has the least decimals. So 3.8, because the number next door was 5 or bigger, so we would round up. Okay, here's our last problem. It says a manufacturing company recently made 3 purchases of an electronic component from a supplier. The company first purchased 60 of the components at $3.68. Its second purchase was 48 at $4.12 and 24 at $4.28. For pricing purposes, the manufacturer needed to know the average cost per component. Well, we've got the $3.68, we purchased 60 of those for that. And then the ones that were $4.12, we purchased 48 of those. And the ones that were $4.28, we purchased 24 of those. Okay, and so this time we want to be careful about what we're adding to. So our total amount of these components are 60 and 48 and 24. And if you add that together, um, 60 plus 48 plus 24, we're going to come up with 132. 60 plus 48 plus 24. And so on the top, when you add all of this up, or you do the multiplication and then do the addition, this should be addition, you're going to get 521.28, and we want to divide that by 132. Okay, and that's giving me 3.9490909, and it just keeps going like that. And so we're talking about, or once again, we're talking about money. And so we said money, you would round to the second decimal place, the hundredths place. And if there's anything on the right side, so typically with money, we're going to round up no matter what it is. This happens to be a 9, so that would make us round up anyway. So $3.95 would be the average cost for all of these. That's the end of 3.2.